right, so we got 10.1, and we'll start with the warm-up. So you had to find the R, and you can see that we've got a right triangle, and I'm trying to find the missing side. So R squared plus 12 squared equals 13 squared. Remember, this is the Pythagorean theorem, where this has to be the hypotenuse. So I take R squared plus 144 equals 169. Subtract the 144 and I get R squared equals 25, or R equals 5. Okay? All right, on this one we have an isosceles triangle, and you may have found this a couple different ways, but what I noticed is that since it's an isosceles right triangle, this has got 45 degrees and this is 45 degrees. All right, so this is my a root 2, okay? So 18 equals a root 2, and I'm going to divide by square root of 2 and rationalize the denominator, and I get 18 root 2 over 2, or a equals 9 root 2. Now, if you didn't see that and you set up the Pythagorean theorem and you got the decimal for that answer, that's fine as well, all right? Just trying to review a couple of different things. All right, then this piece right here, this one's a little bit tricky. These are my two sides, and then this whole thing is the hypotenuse. So I get R squared plus 64 equals R squared. Now, when you do this, this is the same as R plus 4 times R plus 4. Okay, so when you do that, you have to distribute R squared plus 4R plus 4R, or some people like to call it foiling, okay, and then simplify. I can subtract the R squareds on both sides, and I'm going to subtract the 16, so I get 48 equals 8R, divide by 8, and you get that R is 6. All right, so let's talk about our lesson today, all about vocabulary with circles. So I already filled this out for you so you guys can kind of pause and just look at it, but I'll talk through. So a circle is the set of all points on a plane that are equidistant from the given point. So the circle is defined as all of this around that's equidistant from the center. The radius goes from the center out to the circle, right? And it's a segment. The chord is also a segment, and it goes from one side of the circle to the next side of the circle. The diameter is a type of chord, so one side of the circle to the next side, but it has to go through the circle. Notice that the diameter is twice as big as the radius. All right, a secant is a line that intersects the circle at 2 points, so it's going to go through. Notice it's a line, all right, that's a big key here. So when you're looking, you're going to want to see a line. A tangent is a line, but sometimes it can also be a ray, but it intersects the circle at 1 point, so it's only going to touch at 1 point, and that spot where it touches is the point of tangency. Okay, so now we have to identify in this example the special segments and lines. So tell whether it's a chord, a radius, a diameter, a secant, or a tangent. Okay, so A to C, first of all, we know it's a segment, and it goes from the center to the outside, so this is a radius. A to B goes through the center and goes from one side to the other, so it's a diameter. And then D to E, you can see it only touches at 1 point, point B, so that's a tangent. And then A to E, it goes through the circle and touches at the 2 points, but it continues on, so it's going to be a secant. So be careful with the difference between a secant and a tangent, and a chord, right? A chord is going to stop from A to G, okay, whereas a secant is going to keep going on because it is a line. All right, I'm going to have you guys try the practice on the back, and then I will post the answer key of all of my notes, and you can see the different pictures and things like that.